Hello everyone, welcome to this LD Talent Blog screencast. Today we'll be discussing on how to set up an optimized MongoDB replica set on AWS EC2. This blog was written by Olumuyiwa, an engineer at LD Talent. You can click on his name to get to his profile to learn more about him. So now let's get into it. MongoDB has become the go-to choice for web developers, especially within the dynamic JavaScript ecosystem. Its document-based NoSQL design and seamless JSON integration offer two major advantages, which are massive scalability and using JSON everywhere. By leveraging MongoDB's scalability and JSON integration, web developers can efficiently address the challenges of modern data-intensive applications. MongoDB stands as a good solution, enabling the creation of robust, scalable, and flexible applications that meet the demands of today's digital landscape. This guide aims to equip you with knowledge to build a well-tuned MongoDB replica set capable of supporting up to 10,000 customers in a production environment. Deploying MongoDB either locally or via MongoDB Atlas offers simplicity and convenience. However, transitioning to a self-managed MongoDB in a production setting introduces new complexities that demand a more refined approach. You will notice that online resources for MongoDB deployment in production is cluttered with outdated guidelines, incomplete advice on data modeling and query optimization, and strategies that don't fully address high availability and fault tolerance. This guide here assumes a couple of things before you go on, which is prior experience with web application development using Node.js and the foundational understanding of MongoDB. It also presupposes experience with AWS for deploying services and an appreciation of DevOps practices in enhancing application development and deployment processes. So this blog is divided into two parts. One is the application development and the other being the database administration. So let us start off with application development. The initial step is establishing a reliable database connection early in the application lifecycle. This ensures seamless interaction between your application and the database across different stages of development. When considering connections, there are three sets of environment we should be aware of. First, the local environment where the application runs on the same machine as MongoDB, offering instant connections and an ideal setting for rapid application development and feature testing. On the second, which is staging, here MongoDB might be hosted on a managed service like MongoDB Atlas, while application could be running either locally or on a cloud service. The notable challenge is the less reliable network connection compared to the local setup, necessitating a robust connection strategy to handle potential network instabilities. Which brings us to the third, which is production environment. This is typically hosted on a public cloud. The application must be prepared for the inherent unpredictability of cloud services, including possible service interruptions, implementing sensible defaults for connection retries, timeouts, setting, and failover strategy is also critical to maintaining application reliability and responsiveness. So we have a code snippet that showcases a robust pattern for initializing the web application backend, emphasizing error handling, connection retries, and the use of environment variables to manage connection strings effectively across different deployments. So let's open it up so we can break it down. Off the top, we see it begins. Off the top, we see it begins with utilizing the .env package for non-production environment to load environment variables, crucial for managing different configurations between development and deployment, development, staging, and production. Essential modules like HTTP for creating the server, Mongoose for MongoDB interactions, and app for an app are imported. These dependencies lay the foundation for the application's backend services. The DB URL from the environment variable specifies the MongoDB connection string, which is paramount for connecting to the correct database instance based on the application's running environment. An HTTP server is created with the Express app as its listener, showcasing the integration between server and the web application. The strict query configuration is set to ensure compatibility and to address specific behaviors in Mongo's handling of queries and optimizing for the application's needs. A retry mechanism is implemented, establishing a connection to MongoDB, enhancing the application's resilience to the transient connection issues. This is particularly important in distributed environments like deployments and cloud deployments where network reliability can vary. Connection options such as auto index, max pool size, and min pool size are fine-tuned to balance performance with resource utilization, crucial for scaling and maintaining responsive interactions with MongoDB. The script also includes a handler for graceful shutdown on receiving a signal, ensuring that database connection is properly closed and the application exits cleanly. This is an essential practice for maintaining data integrity and application. Now we'll move to the second part. So we're addressing the application type concerns. The understanding whether your application is read heavy or write heavy is pivotal in optimizing MongoDB's performance. Read heavy applications like e-commerce platform and social media feeds primarily fetch data. For this, preference flag on the setting the read preference flag on the connection URI, then directing the reads towards secondary node can alleviate the load on the primary node and enhancing the performance. While for write-heavy applications such as tracking systems and payment processing systems, predominantly mutate data, strategies like implementing queries, queues for non-time sensitive operation or splitting the application to multiple monoliths, each with its own MongoDB replica set can help maintain responsiveness. Here we have an URI which incorporates the critical parameters for both application types, ensuring high availability, fault tolerance, and performance optimization. In this format, let's break it down. We see the credentials and the server DNS host names for replica set members, the replica set name, the retries policies for read and write operation to undo network partition. Write concern is set to majority for data integrity. A read preference for secondary node to balance the load. And we have to optimize our data. So the initial step towards optimizing performance is to understand your application's query patterns. This is this understanding guides design to the design of your model of your data model and selection of appropriate indexes. Storing related data together in an embedded document is recommended when feasible. This approach can significantly impact the performance of applications and databases in a production environment. A practical example is a photo gallery application where users can upload photos stored in AWS S3. The user dashboard displays thumbnails of the most recent photos with features of pagination and infinite scrolling. Also, the feature to view the full size of the the full size of the photos. The key takeaways from this are we need to tailoring the data model setup according to your application specifically, whether read heavy or write heavy enables more efficient data processing and better resource utilization. Thoughtful data modeling emphasizing the relationship between data entities and leveraging MongoDB strength in handling documents lay the groundwork for a scalable, high performance application. The initial data model for the gallery includes user information and and an embedded array of photo. Let us open this in the code base to see what it looks like. We notice that each photo has attributes like file name, creation date, full size, and thumbnail links. While the model seems while this model seems intuitive, it encountered a scalability issue due to the unbounded size of the photo array, potentially exceeding MongoDB's size limit. To address scalability and performance, the model undergoes significant refactoring. Photos are moved to a separate albums collection, which is which which is created here. This modification adheres to MongoDB's preference for smaller, more numerous documents, enhancing performance. The user model, the user model, the user model retains essential user attributes and introduces an album field, replacing the photos array to reference the album's collection. The album model, what we have here, stores information previously held in the user model. Each album document links back to its owner, facilitating efficient data retrieval. For performance and scalability, by structuring the data model, the application can now efficiently manage a large volume of photos with minimal performance degradation. The refactoring simplifies data retrieval processes, allowing for more straightforward and performant queries. This model better accommodates the dynamic nature of user-generated content, ensuring the application can scale alongside its user. The provided code snippets detail the schema definition of both user and album, emphasizing the importance of secondary indexes for enhancing query performance. So we have everything here that encapsulates everything that we need to do. Here we have example of queries that can be performed on the user and to get albums and photos from the user model based on the refactoring we did earlier. So now let's get back to the second part of the blog, which is database administration. In the second part, which is database administration, we focus on setting up MongoDB for production environments through efficient database administration practices. In production, MongoDB is never deployed as a single node service. The two recommended architectures are replica set and sharded clusters. This guide emphasizes the importance of using replica sets over sharded clusters. Replica sets in itself are recommended due to their simplicity, reliability, and performance benefits, which align with the advice from the MongoDB's chief architect. So the first step here is reviewing our needs. So the key to supporting app deployment and development is leveraging DevOps practices to deploy MongoDB replica set on AWS EC2 using Ubuntu 22 AMIs. Ensuring instances are auto-configured with MongoDB and can rejoin the replica set autonomously after they fail. The goals include using a permanent DNS host name for replica set members, enforcing regular data backups, automating it to minimize human intervention and adhering to best practices. The tools of the trade that we're going to need here are the EC2 launch templates, the auto-scaling groups provided by EC2, AWS security groups, network load balancers, IAM roles, AWS S3, simple image service, bash scripts, Ansible, and a Node.js notifiers script to achieve a high availability and fault tolerance and self-healing MongoDB replica set. After we have all of this, then we go into setting up the S3 and IAM role. We initiate the creation of an S3 bucket for backups and a custom IAM role for simple image services and S3 access. Then we go to the next step, which is identifying replica set requirements. Goal is to aim for a 3-member replica set distributed across AWS availability zones with roles assigned as primary, secondary, which are facilitated to support high read and write throughput, and a hidden node dedicated to backups. This necessitates 2 Ansible playbooks for configuration, 2 bash scripts for backup and restoration, production grade config files including the mongodb.conf file, a sshq file, and a system md service file. Then our next step is to create network load balancers and target groups. So when we shift to the infrastructure, the focus is on creating AWS EC2 network load balancers and target groups for efficient routing of MongoDB traffic, which operates on TCP 27017, which favors network in which we are favoring network load balancers over application load balancers for broader protocol support. And we have our next step, which is creating EC2 launch templates. The creation of EC2 launch templates for MongoDB instances, emphasizing auto-scaling, selecting Ubuntu AMIs, instance types, security settings, and user data scripts for configuration upon instance launch. Then we move to creating auto-scaling groups. Establishing auto-scaling groups to manage the replica set node, ensuring they maintain desired capacity and performance. This includes naming conventions for easy management and leveraging network load balancers for consistent network performance. Configuring the replica set and database. So we are going to finalize this the replica set setup, which involves SSH into the primary node to initiate the replica set and add members. It also includes ensuring public DNS resolvability for the primary node and setting up initial database permissions. Then finalize by testing the replica set performance. So conducting a series of tests to verify the replica sets functionality, including connectivity, write read operations, backup success notification, and resilience to instance failures, ensuring high availability and fault tolerance of the deployed MongoDB replica set. So with this said, this I hope this guide has been able to help you create a new MongoDB replica set. You can always come back to this to as a reference when you have any issues or if anything comes up that needs to be verified or rectified. Have a nice day. Thank you.